Okay, so everyone, welcome. We have two classes for the first time. So what I'm going to do just as protocol is I'm going to have both of my Slack channels open for full stack fall and winter. So as you are listening, whether it's a screencast portion or just me right here, enter in your questions as they come up, and then I'm going to monitor them on the screen, and then I'll answer them as soon as I look down. So just keep that in mind. Also keep in mind there is about a 10-second delay on the live video streaming because it also is recording at the same time. So if it doesn't seem instant, it's because it's not quite instant. So I will keep both these open and I will be checking them. Also, if I ask, do you have any questions on that? Someone just respond back if no, with no if the answer actually is no, so that I don't wait on it. Okay, so what we're going to talk about today, and welcome cohort 2, the winter class. This is the first kind of deep dive live lecture that we've had together, and so this is going to be a really good one. This is going to be focused solely on how to work with Git in regards to application development. So and I'm switching to the screencast portion right now. We're going to start on the very beginning of Git. And one thing I want to send to you guys, cohort 1 already has it, but for cohort 2 you have this. Let's see. This is going to be a Git cheat sheet that you can follow along with. So right here, this is, if you open this up, this will have all of the various commands that you're going to need, and these are pretty much the ones for the most part, you're ever going to need. So this is where we're going to kind of be following along throughout the whole course. Perfect. Okay. So yeah, and as Braden said, do not code along with this, because the reason is, even though I'm going to walk through all of the commands that you'll need, and they're all here on the Git cheat sheet, there are certain things that if you do not have Git installed on your system are simply not going to work. So like Braden said, don't follow along, simply kind of follow along with just watching for group 2. But group 1, you definitely can follow along. And I am going to go through everything from the very beginning. I know some of this for group 1 is going to be a little bit of review. However, because Git can be a little bit of a complicated topic, I wanted to kind of just review some of the items, because if you're like me, the more times you hear it, the more it's going to make sense. So I'm going to switch over to the command line. Okay, good. I'm glad the audio sounds better here. So I'm going to switch over the command line, and I'm going to just switch into a code directory, and I'm going to create a new directory here. So I'm going to create a directory called just Git demo here, and then change into the demo. Now, the very first thing that you'll do whenever you are creating and working with Git is you have to run git init. This is going to initialize the Git repository inside of this location. So now if I type ls-a, you can see that we have a hidden directory here called Git. And this is what does a lot of the magic for us with Git in terms of doing tracking and all kinds of things like that. So now that we have that, we can actually add some files in. So I'm going to type some files. So I'm going to say vim, just some Ruby file. And inside of this, I'm going to just add some content. So I'm going to say, let's just add an array of 3 elements, and that's it. And just in case you're wondering, I'm using the Vim text editor. You can definitely follow along in Sublime Text. I'm not going to do anything that you can't do in Sublime Text on it. I'm just doing it so that we're not having to switch windows in the screencast. So here I'm going to save the file, And now if I type in git status, this is now going to tell me some very important information. It's going to say which branch I'm on, and I'm on branch master, and it's going to tell me that this is the initial commit, which means that we do not have any other commits that we have to worry about, or there's nothing else that we can go back to. And it tells me which files are untracked. So to add files, there's a few things I can do. I could say git add with a dot, and this would add all of the files that are untracked in this directory. I could also be more specific, and I could type the exact file that I want to add. So here I'm going to type in git add some Ruby file, hit return, and now if I type in git status, it's going to change the color to green and show that this file needs to be committed. So as you can see, the first two items are the same. We're on branch master, and this is still the initial commit, but now it's saying the changes to be committed are these items. Now say that we made a mistake and we don't want to actually commit these changes. I could do something like this. I could say git checkout some Ruby, oh sorry, not checkout, sorry, git rm some Ruby, and now I would be able to, there's already a cache version, so right here I'd have to force it. And so you can cache it, or you can force it with a -f if you do want to force it out. But if you do want to add it, then you're going to say git ci-m and then give it a commit message. Now this message is just going to be my first commit. And now it's been committed, which means if I run git status, there's going to be nothing to commit, and it says I'm working on a clean tree. Now let's actually open up the browser and navigate to GitHub. So if I come to GitHub, I can come and I'll create a new repository. So I'm going to click on new repository, and this one's just going to be git demo here, and I'm going to keep it public. All I'm doing here is I'm creating a centralized repository for the application code. So I'm going to create this. I don't want a README or anything like this. I just want an empty repo. And then from there, I have a number of options. So here it gives me a way of quickly setting it up. It gives me the ability to create a brand new repository completely from scratch, or to push an existing one from the command line. Now, this one is the one that I go with probably about 99% of the time, because I usually start off with a Git repository locally, just like we did before. And a question just came through. It said, would you please explain what the CI command is? Yes, CI is just an alias for commit. So if I were to come here and say vim some Ruby code, if I were to come here and make a change, so I could also put some array stuff in here. Now if I save the file just like this, now I'm going to be able to have something else that I can commit. So now if I type in git status, I have something else I can commit. I can add it, and the CI command is just an alias for commit. So I could do CI, but I could also do commit-m, and it's the same exact thing. And I'll say updated file, and that's all I have to do. And now we have two items that we've added, two commit messages. Okay, and thanks, Andrew, that was a good question. And everyone else, if you have any questions whatsoever, just put them right in the channels there, and I will answer them as they come up. And definitely you can tag me in them as well, so that it will pop up on my notifications and I'll know right away. Okay, so next thing, now that we know that we have our repository locally, this means that we need to come here down to this third option, and I'm just going to click copy to keyboard. Coming back down, I can paste this into the terminal and run it. So what this code is going to do, let's look at it, is the first line adds a remote. So what a remote means is that right now, when I created that directory and I be in there, that was a local Git repository. But what we want is the ability to actually share our code remotely. And so what we need to do is create a connection between this local repository we have here and the remote one that we have right here on GitHub. So that's all that that's doing is we're adding, it takes in origin, which is just the name of the remote. You could name that anything, but the default's to use origin, so that we're just going to keep the default. And then we pass in the URL. Right here you can see it's github.com/Jordan Hudgens, which is my username on GitHub, and then getdemo.git. So that is, as you can see right here, that's exactly what we have. And then the next command is git push-u origin master. Git push is a command you're going to become very familiar with anytime that you want to push up a change to a remote destination. You're going to run git push. You only have to run this part when you are doing your very first initial commit. So this -u origin master, you're not going to have to do that again. From now on, you can just run git push. By default, it's going to push up what's called your master branch. So now if we come here and we just refresh it, you can see that our code is now live on the site. So I could click on some Ruby and you can see all the code that we had and we created here has now been pushed up here. So are there any questions whatsoever on what we've talked about so far? Okay, I'm going to take that as a no and I'll continue on. So switching back now, I want to start. Oh, we got one question from Andrew. And are we going to expand on upstream? Yes, and we will talk about upstream, but I first want to actually get into actually making some changes on the repo itself. So coming over to the Git Cheat Sheet, I want to kind of show you what each one of these commands is for. Basic commands, as you can tell, we just covered a bunch of them right here. So we already covered almost all the basic commands, such as git init, and then git add with some options, and then git commit with the git messages. Next thing we're going to cover is Git Diff. Now this is a very powerful tool right here because what Git Diff allows you to do is to see the differences in files versus what you've implemented and what you're wanting to change. So let's open up some Ruby file again, and this time I'm going to add another couple elements. So I'm going to add 2 more elements to the array here, and I'm going to save this. And now if I type in git diff, what this is going to do is it's going to actually give me a report of what the different items are. Now the way that Git works is it shows you the line numbers, it shows you the files on what items have been changed, and it also shows you the actual contents of what have been changed. So here we have the item that is the old version. The negative stands for this is the old version, and then the little positive sign, this one is the new version. So these are the changes right here. So we have the 1, 2, 3, 4, and 5. Now, if I look at that and I'm like, oh, I don't really like that, then I can run git checkout and then pass in the file name. And now if I type in git diff, then you can see that there's no changes. And if I type in git status, then nothing is changed on this side. So if you make changes to a file and you don't like the changes and you actually want to revert back to the last spot where you committed, then you can just run git checkout, pass in the file name, and then that will remove those changes so that you don't have to that you don't have to implement those. So that is how you can run Git Diff to check for those items. So those are all the basic commands. Those are the ones that you're going to be using on a day in, day out basis. Now, to talk about a little bit what Andrew was asking, and we'll get into this even much more, is the concept of the way that Git works with the upstream and the downstream. Now, there's some confusion around it. The easiest way of thinking about this is, say that you have a full set of team members. So right here, let's actually draw it out. We'll draw it out in our Ruby file here. So say that you have a bunch of team members here, and so we're going to have Andrew and Curtis, Braden, and myself. I guess I should put my name. Okay, so you have each one of us are working on the single project. Every time that, say, Braden makes a change and that he actually pushes up, he is going to push that change up. And so let's say that it's some feature like adding authentication to the system. As soon as he does that, what he's activating is the upstream component of Git, which he is pushing up to the system. So if we say adding auth, it falls into the upstream kind of part of Git. Now, when this happens, all of us, so Andrew, Curtis, and myself, we need to be able to pull this item in. So in order to get our items so they're matching, then all of us are going to run git pull, and I'm going to walk us through this. And we could do git pull or git fetch. And what this is going to do is this is going to activate the instruction of Git. And so if each one of us do this, then it's going to be the same for myself, for Curtis, and for Andrew. And then when we've done that, then all three of us are going to be lined up and have the same exact code. Now, I personally, I'm not a huge fan of talking about upstream and downstream when it comes to Git, mainly because I think that it's kind of a functionality that's simply built into the system, and the concepts of uploading and downloading files to get them to match, I think, is actually kind of self-explanatory once you've gone through it enough times. So these are the official terms that you'll use. However, I don't get caught up in thinking that there are these giant concepts that are really difficult to wrap your head around. Simply know that when you push something up, you're activating the upstream mode, but you'll never type in upstream or anything like that. And then the other one is downstream, if I could spell it properly. And this is what happens when you're pulling it down so that you have access to the code and you can get lined up to, in this case, into Braden's code base. So let's actually take a look at this. So let's go into branching, and we're going to return back to talking about upstream and downstream, at least on a practical basis. So here, let's pretend that we have a giant feature that we have to build. So we want to build in some kind of permission structure, and we could technically start work on it right here. But the problem with this is, let's imagine that we want to create a special feature, so a permission structure feature, but while we're doing that, we get asked to come back and to make a very small change to some other part of the application. So let's start building out our giant permission structure feature. So permission structure.rb. If we do this, now we could, put in whatever kind of permission stuff that we have in here. Let's just pretend we have a giant code base in there for managing our permission structure. And let's say that it's only about halfway finished. Now, that's not a huge deal if you don't have interruptions. However, in real life scenarios, what you will see, and you can ask Curtis and you can ask Braden about this, is as you're building out one of these features, 99 times out of 100, you are going to get interrupted and someone's going to come and ask you to do something such as making a small change to the live application. So say they found a little small bug or a spelling mistake or something like that. If you are working on the master branch, so if you're working right here, what you're going to have to do is actually go back and make and reverse all of the changes that you implemented on the permission structure. And you'd have to do that because your permission structure is not ready for the live site yet. But if you have to go out and make changes to the live site, then you're kind of in a pickle. You either have to finish the permission structure really fast, or you're going to have to reverse all the changes and then go implement the small fix. So the way that I'm going to do this, so I'm going to see what we have here. We have Git status, and we have 2 changes here. Well, that's really not a good thing because we implement a little hot fix. So what I'm going to do is let's pretend that we did this the right way and we're starting from scratch. So I'm going to say git checkout, some Ruby, and then git checkout, or I'm actually, this one we haven't even committed, so I'm just going to say remove permission. And so now if we run git status, then we're lined up with master. So we're saying that we were lucky enough to get a time machine and we were able to come back in time and do this right. So what the right way to do this, if you have a big feature to build, is to create a branch. So I'm going to git checkout -b, and then we're going to say permission structure. What this is going to do is it's going to create a special feature branch here that is going to allow us without having to actually affect the actual master branch. So as you can see, because I did git checkout -b permission structure, this actually created this branch and it changed us onto this branch. So let's actually take this for a little bit of a spin. So if I type in vim and some kind of permission.rb file and just put something inside of it, this is our half-baked permission code inside. Now if I run git status, then it's right here. But now you say if the client comes up to you, they have some immediate fix, it's really urgent, you have to get it fixed. You can actually just save this file. So I can say git add, git commit, and save the stage of it. So I'll say initial implementation of permission structure. And now if you type in git status, you can see that there's nothing to commit. And if I type in git checkout master, then you can see I'm switched to master. And if I type in ls, you can see our permission structure file is gone. And it's not really gone, it hasn't disappeared. It exists only on this special branch. So here I can, if I check it out again, so if I hit git checkout permission structure and type ls again, now you can see that we have both of those files, and that's then you could get back to working on it. But I'm going to say git checkout master. I'm going to implement the fix. So let's say that that fix was some type of spelling mistake or something like that. So let's say the client said we needed to put a period here. Now if I run git status, I can make these changes, commit all of them. So fix spelling mistake, run git push, and now everything is fixed. And if you come back to our Git repo here and hit refresh, you can see that all of this part is fixed. And now what we can do is actually get back to working on our isolated feature. So let's come back. To see all of your branches, just type in git branch, and you can see that we have our master branch, And the little asterisk means that we're on master. And then we have our permission structure one. So to do this, we can type in git checkout permission structure again. We're back to it, and we have both of our files. Now, let's say that we finished this out. So we are good to go. Everything in the code has been tested, and we're ready. What we then can do, if you reference your cheat sheet, is now we can actually push this repo up to GitHub. But we're not going to push it and merge it in yet. We're actually just going to push it up so that we can compare it with what we have over here. So here what we can do is type in git push origin and then whatever the branch name is. So in this case, it's permission structure. And if we do this, then this is going to push our branch up, but it's still not merged. Right now, as you can see, GitHub auto updates in the background. So you can see that our permission structure branch is now here and it's ready to review. And what we can do is this gets us into the next stage of using Git, which is to create pull requests. So what a pull request is when you have implemented a feature, instead of just merging it straight into the master branch, because that could create all kinds of trouble if done improperly, what a pull request that you do is and Git actually checks a bunch of different parameters to make sure that it actually is okay to merge. So here it says open a pull request, and it does a validation to make sure that you don't have any kind of conflicts. And if there are any conflicts, it'll give you a little red X here, and then you'll have to go fix the conflicts. Conflicts typically are just when you have one of your that has been overridden by another one on the master branch, and it would create a problem in trying to merge those two together. And we're going to walk through exactly what happens when a conflict occurs later on. So now that we're here, we can say, added permissions, and then lots of other stuff. One cool thing about using pull requests in GitHub is you can put anything in here that you want. So this gives you the ability to add links, do actual code. So you could say something like, say that this pull request was really complicated and you created a view helper or something. You could say permissions can be called within the view with code, and then down here pass in the type of code you want. So it could be something like user admin, something like that. And then when we hit create pull request, this description is actually going to be formatted so those little dashes turn into bullet points, and that when we use the code snippet pane, this actually converted it to look like real code. So that generated the pull request, and now we can just click merge. I'm going to click merge here. And now, if we come back to GitHub, you can see in the master branch, if you click on branch here, you can see we're on the master branch. Now you can see that our permission is right here with all the code that we put inside of it. And the other thing that you have to do is come back to your local repository. And this is whether you did the change or someone else did. We're going to come back to the master branch. And now we can run what's called a git pull. So what this is going to do is it's going to go to the remote repo and it's going to bring down all of those changes so that our master branch here locally lines up with it. So if I run that, you can see that it pulls in, it counts the objects, it compresses them, then it shows you the total number of them, and then it goes and it uses what's called a fast forward. And this fast forward merge is part of the downstream process, and it is merging the repo online, the master branch repo, with what you have here locally. So in this case, it's adding the permission file, tells you one file change, and that's it. So now if you type in ls, you can see that all of this now is up to date. So are there any questions with where we're at right now? And yes, Andrew, that's what we're going to cover when we go into how to manage conflict. So we're going to go over how that works when we have multiple users all working on the same repo. So yes. Okay, so continuing on. Right now we've talked about branching, and we've also talked about how we could bring those in. There's one last thing I want to cover on this is, let's imagine that you're using branches and you don't want to go and do the full pull request here. This is usually only going to be the case when you're working by yourself. You also have the ability to do this locally. And yes, that's going to be one of my main focuses. And as you can see, if you looked at the cheat sheet, I dedicated half of it to how to manage merge conflicts. So even Nick Cage even made an appearance. So yeah, we're going to go through exactly kind of a practical way of managing merge conflicts. Okay, so let's talk about how we could do this from just kind of a single user perspective, because I think the more you understand this side of it, the easier it's going to be for you when you want to understand how to do it with other users. So I'm going to create another branch here called some other feature. And inside of this, I'm going to just create some other file, it doesn't matter what it is. Put something inside of it. And now we are good to merge it in. So what we can do is check it out, add it into our repo, and add a commit message. So we can just say feature is done. And so now it's committed. So make sure you always go through that process, because if you skip that process, then you're not going to have anything to bring in. You have to add all the items in and then commit them. And then once you've done that, then it'll be ready to merge. So the process for merging is check out the master branch. So I'm going to hit git checkout master. Then if I want to see all the branches, type git branch, and then type in git merge, and then we're going to do some other feature. So now if I do that, it gives the exact same code here, if you notice, as when we pulled down from the remote repository. So if you're working on an application just by yourself and you don't really have to worry about pull requests and those kind of things, because the reason behind having pull requests is so that you can work with others and you can try to avoid conflicts with, where you wrote some code that had a conflict with someone else's code. If it's just you by yourself, you can do all of it just like this. And now if I run git status in the master branch, then everything's going to be fine. And if I hit ls, you can see that that new file that we added is right there. So we're good. And that's how you can manage it locally. So for example, right now, I have a few projects I'm just doing completely by myself, and this is the way that I do it. I still use branches because there may be times where I need to go and switch to the master branch to perform a quick fix, and I don't want to have to get rid of all the code that I wrote. So I still isolate it all on the different branch, but then I don't have to worry about pull requests or anything because I can do it all right here. Okay, no questions on that. So that's on branching. Now, I also kind of talk about stashing a little bit. So what stashing is stash gives you the ability to, if you're working on a branch and it's not ready to add those items or to commit those items. So let's say that you have a very urgent thing. So I'm going to create another branch. I'll say git checkout -b, and we'll say another one. Now that I'm on another one, I have another big set of features that I'm working on. So with this one, let's just say this is auth. And with auth, we're just doing auth stuff. but we're not even close to having it ready to commit. So at least commit in terms of pushing it up and creating a pull request. So if I run git status here and I have this auth file, I'm not ready to actually commit this, but say that my boss comes in and he says, hey, we have this huge urgent thing. I don't want to commit it because it's not ready. I can just add this so at least it's tracked. So git status shows that it's tracked now. And then I can run git stash. And what this is going to do, and it kind of describes what it does, it says saved working directory and index state, work in progress, that's what WIP stands for, on another one, this branch, and then it's not making me commit this item. So if I type in git status, you can see that nothing is there. And then I could go and make changes to the master branch, come back, and then all I have to run is, I believe the command, I don't use stash a ton, but whenever I do, it can be handy. So git stash apply, and now you can see it brought our file back. So this is something that can be kind of an intermediary step. If you have a feature you built out but it's not ready even to commit, then you can stash it and then bring it back anytime that you need it. Like I said, I don't use it a ton. I'll usually be able to have the flexibility to at least get to a spot where I can commit the code. Even if it's not done, I could still get to a stage where I commit it. But in cases where you have something super urgent, then git stash can be helpful. Nothing on that side. Let's keep going down. Next thing is viewing history. This is very helpful. This is probably one of the more common things that I use is git log. So here, if I type in, actually let me run git status, let me add, or it's already added, let me commit this, and let's merge it in just so we can have some more test data. It'll make our log look more impressive. So git added auth, git checkout master, git merge, another one, and now you can see we have 4 files. Now to see the log, if I run git log here, this is going to open up all of the commits that we've ever made on here. And if you use your up and down arrows, or you could also use J and K to move up or down, this is going to show you a lot of good information. It's going to show you the commit. Then it's going to show you the commit ID. So if you ever have to revert back to a specific commit, this is going to be the ID that you use. Then it's going to show you the author. So if I was working on a team with 5 other people, then it could show all the authors right here. And then it shows the exact date of the commit along with what the commit message was. So this is a great example of why commit messages are so important, because if you do not have descriptive items, then you're going to run into an issue where you don't actually know which checkout or which commit you need to switch back to. So say that you did a bad job of commits the way I did right here with added auth. Feature is done. I've actually seen developers put these into production applications. This is nearly impossible to work with because I don't exactly know, what feature is done right here. I need to have more details. So here, this is better. I integrate the initial implementation of the permission structure. This tells me a lot more in regards to what I actually need to know if I'm going to switch back. So that is that side. Now to get out of this, just type the letter Q, and that's going to quit right from there. Now there's some other things. They're not used quite as much. I usually just use git log, but if you need to see some other things, you can actually run, and I included them here for you, you can get the full log on a single file, and you can also run, I think it's a funny name they chose, called this git blame command to see who changed a specific file. So let's take a look at this. So if I run git log and let's see let me see our names of files here. So ls, okay, so if I run git log and some Ruby file, then this is going to show the commits that are specific to this file. So where this comes in handy is when you have a situation where you need to see all of the changes, but you don't really feel like going through the entire set of Git log changes. What this can do is just allow you to focus in and say, okay, which changes occurred at each stage. Now, what you have here on the command line is fine, but you may also want to use the website for this. So if you come up to the website and click on commits, this shows you all of the commits that have been pushed up. So let me actually run git push, because we have even more code up there now. And if I hit refresh, you can see that we have all of these other items here. Now, usually when I'm analyzing any code issues related to Git commits or anything, I usually will use the website just like this because it does a great job of giving you a visual on what happens when code gets pushed up. So if I click on, let's click on fix spelling mistake. If I click on this one, it's going to show me exactly what happened here. So it's going to show me what changes specifically were made. It shows me the line number, and the red in the left portion is the way it used to be. This green portion over here is what got added. So that's how you can compare them. This was a change, just a very simple change. However, you'll run into applications where you have massive changes. So just to give you an idea of more of a production application, let's open up DevCamp and look at these commit messages. So far we've had 446 commit messages. And so every time I add even a little feature, it all gets added here. So this one was called Integrated Fix for Content on Submission Partial. Notice how specific this is. I try to be very specific with these messages because I want to be able to look back and see exactly what was done. Also notice that I used a pull request even though I was just doing it by myself. I just did that because I like to at least follow best practices when I can. So if you click on this, you can see what actual code would look like with kind of a basic kind of change. So here is pretty standard. Just I wanted to add one word on the DevCamp side on a view partial that I created. Let's see another bigger one. So updated login. That was a tiny one. I think this is a big one. Yeah, so here's a really big one we have. So this includes everything from bug history to style changes. But hopefully you can see how much different this looks compared, to our kind of contrived example. This is the kind of thing that you'll be able to see when you're working on real applications, is code that looks like this. So that is, just giving an idea of the reporting interface that GitHub provides. Now, do we have any questions on any of that so far from either group? Okay, I'm just going to continue on. Let's go back to the cheat sheet. So Git's great. One of the really important things that you do with Git is the ability to reverse yourself. And so the concept of that is called reverting. And we've already shown how we can revert back and remove any changes by doing git checkout and then passing the file name. However, Git also has a concept of Git Reset. So what this does is it can reset all the changes you've made. So let's say that you made a big feature, you tried to make a big feature, and you really didn't like the implementation. I don't care how long you've been developing, that is going to happen. So right here, let's actually take this for a spin. And I'm not going to switch to a different branch. We'll just do it on master. Usually, you'd obviously be building this on a different branch. But I'm going to say just vim, and we'll say bigfeature.rb. And it doesn't matter what we put inside of it. And we have git status. And we could even, we could create a few other files. So I'm going to create big feature. And we'll create big feature 2. And now you can see we have two big feature files, and if I run git status, we have these items. But let's say that we don't actually want to have these, and we don't want to go line by line in order to go through and check them out. Obviously, it's not that big of a deal just with two files. However, let's imagine that you did this in Rails and you ran a scaffold or you did some kind of generator and it created 30 files for you. You would not want to manually go through each one of those and remove them. So that's exactly where this comes in. So you can run git reset --hard and then head. And what this is going to do is the head is the head commit. It's the last commit that you made. And so this is resetting it. You have to give the hard flag in order for it to revert back. So now if I run this, then it says head is now at, and it gives the commit where it said added auth. Now if I run git status, those items are still there because I need to actually add them. So this only works when you've actually added them so they're being tracked. You can't, the only way to get rid of these is to just delete the file. So first you have to add the files in, and then once you've added them, then you can run this. And if you run git status now, you can see that it has reverted back, and now if you type in ls, both of those files have been removed. So that's the way you can do that. Now we're going to get into the fun stuff. So this next portion is probably the part that is the most intimidating when it comes to working with Git, which is to manage conflicts. So let's take a base case scenario here. I'm going to create a README. And as just kind of a side note, README, all capitals, .md, a file that you give that has those items and has that title, what that's going to do is it's going to be the item that gets shown here on the home page. So what you notice how this is blank right here, but compare this with like say the DevCamp code base. You can see DevCamp has a full set of items here in the README. Usually this is where you'll put instructions. So this is where I'll put how you can run it with subdomains, some definitions here for the way the model organizations work. I put the full color style guide here, how to get to icons, and then some kind of secret things that are, if I didn't put them here, I'd forget how to do them. So that is what you usually would put in your README. So here it's empty, and it's because we don't have a README file here. Now if I type in, this is our Git README, and I add this. Now when I push this up and hit refresh, this is now going to have a README right here, just like you can see. So this is all fine and it's all well and good, but I want to actually show what it would be like if we had a conflict. So the easiest way of showing that is just right here. And we're going to pretend that I am two people at the moment. So let's say that I'm working on the README here and I create some changes. So I'm going to come up here and put some type of important instructions with some bullets and save this file. So if I run git status, git add, and git commit, so I'll say updated README. I'm not going to push this because watch what I want to do. Right here, let's imagine that we have another developer and they make a change to the exact same file that we want to work with. So here we can come in and I'm going to open up the README file. Technically, GitHub allows you to edit the files on the site. You never do this. That'd be a very bad practice. It's possible, definitely not recommended. But you can come here and let's say that I came and I decided as another developer to make other changes. So I could say my set of instructions, and then put some other items here. So I could put my 2 cents, and as you can see, these are different than what we have here locally. So developer 2 is going to create a conflict because we have things that are different. So here I could put here changed instructions, and it's going to commit to the master branch. So now if you look at the home page, you can see that this is live. Now, if I try to push my code up here locally to that remote branch, it's going to give an error because it's going to say the remote branch has items that you don't have. So if I run git push right here, it gets rejected. So it says rejected, it says failed to push some refs to here, and then it gives some hints. It says updates were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same ref. You may want to first integrate the remote changes, e.g. git pull, before pushing again. So what we need to do is, and this is a common pattern, whenever I'm working with a team, I always make sure that I run git pulls before any git pushes, just to make sure that I'm not causing any conflicts. So if I run git pull here, this is going to pull those items down, but because we both edited the same lines, then you're going to run into problems and it's not going to be able to merge it. It's not because there's even an error. That's the one thing out of, if you only remember this part of this entire lecture, is these are not bad things. Yeah, I know it kind of looks scary because it has words like conflict and it has words like rejected. However, these are not bad things. All it is Git trying to help you make sure that you have the right code in place. That's one thing that helped me get through this a lot faster when I was initially learning how Git worked, because I was running into these kind of problems all the time, and it was really annoying. I eventually got to the point I was really sick of it, and I wanted to switch back to the way I used to do things, which wasn't to use Git at all. However, after I started to take more of the attitude that these are simply tools for helping me fix some problems and making sure that I had a clean code base, it made me feel a lot better. So let's see exactly what the problem is here. I give a step-by-step guide in the cheat sheet for how to do this. So first, we start off with git pull, and then it gives us an error message just like we saw right here. Then I show you what your response is probably going to be, and then I show you actually how to fix it. And I give you some words of comfort right here. So whenever you get mad at a git conflict, just read those ones. So what we can do is run git status. So if I click git status, what this tells me is both modified. And what it's telling me here is that we have two items that have modified the README, and all we have to do is open this up. So if I type in vim readme, or if you're in Sublime, open this up in Sublime, this shows you exactly where the conflict is. So this is one. I know this looks scary because the first time I ever saw this, my first thought was, what in the world are all these scary looking characters? I have all these shovel characters, I have this head character, and then I have this gigantic number here. But so let's break this down. Right here, as you can see, this is the head. This is the beginning of what we started to do. So the first portion of this is going to show the changes that you personally made and that you want to have merged in. The second set, the things right after all these equal signs, these are the things that are causing the conflict. So if you notice, this is all the code that the other developer put in and merged into the master README before you got a chance to. So that is all it is. And what Git is letting you do with their conflict management system is it's giving you a choice. So it's saying, what do you want to do? Do you want to take your instructions, or do you want to take theirs, or do you want to do something like this? I can come here, just like this, and actually include both. So let's imagine here that we actually have a situation where we're like, oh yeah, our instructions were right, but the other developer, they had some good stuff on here too. I like this, and we'll take out the third one because we already had that one listed. So we're going to keep all of my work and some of the other developers' work. Now we can save this file. Now if we type in git status, you can see they've both been modified. And if I type in git add, I can say fix conflict here. Now if I hit git push, now everything's fixed. And that's all you have to do. So now if I come back over here, hit refresh, you can see that now all of the code is actually right, and we successfully merged that in. So we were able to take the code that I wrote and the code that developer number 2 did, and we're able to make all these changes. So I have one more example on this, pretty much identical, but I want to show you one other thing that can affect Git. But before I go into that, I wanted to stop. Do you have any questions on that process? Because I know that was the number one thing that was kind of messing people up, was figuring out how to navigate through merge conflicts. Okay, awesome. So hopefully that makes sense. I want to show you one other thing on this. Let's open this file up. I believe it's this one. No. Now let's actually create let's create one more file. I'm going to say vim and more details.rb. So this one is one of the most annoying things as a developer you are ever going to run into. Here, I'm going to create tons of text. And I'm going to push this up. And I promise you, the more times you work with Git, the more you'll just use it and not even be thinking about what you're doing, because it's just going to come second nature to you. I promise I don't even think about the commands half the time I'm typing them in now. I've used it for so many years. But now let's open up this file. So we have this file right here, and it has a ton of content on it. Let's pretend that we have a really annoying developer, and they come here, and this is something I actually have had a developer do, where they came and they didn't edit it on GitHub, they did it locally and pushed it up, but what they did was they actually just changed the indentation for an entire file. I think they wanted to make it look like they were working hard or something, because they changed the indentation for the entire file. Now, watch what happens when this occurs. So say that you change the indentation there, and let's actually open this up. Look at this change request. So in this change, it literally, even when you change just the indentation, it actually changes every single line in that file. So if you need to change indentation, then just be very careful about it and make it clear that that's what you're doing in the commit, because it's going to freak developers out. It's one thing, when all the code's identical, but if you have this on a huge file, like say that you were to do this on, I'm trying to think of what would be a big file in here. It's not going to be a big one, but yeah, pretend you did it on this organization's controller here. If you change the indentation on the entire file, I would have to literally go line by line to see what changes were made, because it would look like everything got changed. So just be wary of that. But I didn't do that just for kind of the sake of saying what not to do, I also wanted to show you another example of fixing the conflict. We're going to do it the exact same way, but now I'm just going to come in, and I think the more times that you see it done, the easier it's going to be. This file was called More Details. So on this, let's just say that we wanted to change all of these items. So every spot where it says ASDF, we want to change to JKL, just like that. And now we're going to push it up. So say we had a method call change. So git status, git add, and said change method calls. Those aren't method calls, just kind of giving you an example. If I try git push, this is going to fail because the same exact reason. We have conflicts. Now run git pull. We have the same issue, and it says auto merging more details failed and the automatic merge failed, which means we need to come in and do the same thing. So to see which one is causing the problem, you can look at this error message, but git status will also tell it to you. And then I can open up more details, and you can see we have the exact same code here. So we have this head tag right here. This is going to show you all of the code that you had. And then down below, right below all these equals, this is going to show you all of the code that the other developer had. In this case, I don't want anything the other developer had. So I'm just going to delete all of it. And then I'm going to come up, delete this head tag, hit save. Now if I type this in, now I have to show that I've merged the conflict. Now if we come up to this file after hitting refresh, you can see that more details now fix the indentation, and it has all the changes we have, none of the changes that the other developer had. So that, I wanted to give you one example where we merged and we kept some of the changes from both, but then I wanted to show you also how you can just override anything else the other developer did. This is all very technical from the perspective of how to fix a merge conflict. In a real world scenario, you need to contact the developer that you're working with on the project to see what their rationale is. It would be bad practice. You'd kind of be seen as a jerk to pull down all their items, override 100% of it without talking to them. So the best process with this, anytime I get some kind of conflict, I don't do anything. I don't go fix it. I don't do a single thing. I'll usually just send them a message and say, hey, what was going on with such and such file, and I'll send them a link and point out, I'm getting a conflict here. I'll tell them what I'm trying to do, ask them what they were trying to accomplish, and then I'll use that information to decide on which code to keep and which code to get rid of, and then I will push up the fixed item. So in a real world scenario, communication is definitely very important when it comes to conflicts. I gave you kind of a demo on how to fix them, but you really need to also just talk with the other developers in order to know what code to keep and what to throw away. Okay, and I believe, let's see. Okay, two more things, and then I will let you guys go. But after going through that, do you have any questions on how to merge or how to fix merge conflicts? Andrew, great question on if I use any GUI tools for merge conflicts. I personally do not. I know that there's a couple ways of managing it. One, you definitely can download GitHub's GitHub has a downloadable client for all operating systems, and you can use that, and that can help if you prefer to do it. I've done it so many times, and I really prefer, and I think it's a lot faster to use the terminal for it, but it's completely up to your preference. My personal recommendation would be to try both. in this guide, I've kind of walked through how you can replicate merge conflicts without even having to interact with anybody else, because it's going to be what I did in changing the files here. This is identical to as if another developer pushed changes to the centralized repo. So what my recommendation would be to use both tools, practice with both of them, and then see which one you prefer. Now, the other thing associated with this that's very important is if you are working with a team and you are using pull requests, that by itself should take care of 90% of your merge conflicts. So if you are using pull requests and you have, every time you do that, that is going to right there block a lot of conflicts, because as you could see, when I pushed an item up, it verified that there were no conflicts. So in that sense, that is the one GUI tool I will use, is just by using pull request, it kind of does a lot of the hard work for you. And that's just another reason why you'd want to stay off the master branch when you're developing full features and when you're working with team members, because that kind of protects it. They will not merge something in that has a conflict. So that's just another reason why pull requests are so important. Do you have any other questions on that before we get into cloning and rebasing? Cool. Okay, so next one is Git clone. Now this is one that everyone can, at least in group 1, can follow along with. I'm pasting the code in here, and I know group 2, I know you're not following along, but you can still click on the link to go to GitHub, and this will take you to this repo right here. Now, say that you're working on a team and you've been assigned to start adding features to this application. What you can do is come to the GitHub page and then click on clone or download, and then click on this link. So if I click this, I will copy it to the clipboard, and then I can navigate. Right now I'm obviously in the app. I wouldn't be cloning this if I was also the one working on it, but I'm going to pretend that I'm not. Change to the desktop, and I can run git clone, paste in this URL, and what this is going to let me do is duplicate this. Now this will only work for you if you are actually a collaborator on this repo. If you're not, click the little fork button and it'll create your own version of this code, and then you'll have access to the clone or download, and then you can follow the steps I just did. Now in the terminal, if I type in cd git-demo and type ls, you can see that it has pulled down all of those files that we had over there and that I pushed up to the remote repository. So Git cloning is very basic. All you're doing is saying clone the code that is in the Git repository, clone it locally so that I can have access to it. And once you have access to it, then you can go and you can do things like push pull requests up and that kind of thing. A very practical way that this works is say that you as a student, if you ever, and I've done this with a few of the students, is if you ever run into a bug that you want me to look at, what I'll usually do is I'll go to your repo, I will fork it, I will then I'll clone it locally, I'll make my whatever changes or recommendations that I have, and then I will push it up and create a pull request. And then you have the ability as the repo owner to merge in the pull request, and you'll actually update all of your code. So that is kind of a practical way that we use the cloning. There are no questions on that one. I'm going to go down to the very last topic we're going to talk about in this live lecture, which is rebase. So this is one that is important if you are working on feature branches and you're working on a bunch of different things that are taking a long time, and the master branch has updated since you started working. So let's take a scenario here, and we'll actually walk through it. So let's think of something. Let me close out of this, and I'm going to work on a special branch. So I'm going to say Git checkout, and this will be special branch. Oh, sorry, I forgot to do -b. Git checkout -b, put me on special branch, and now I can work on all kinds of things. So I can create special.rb and put anything I want inside of it, and just keep on humming along, keep on working on it. Now let's say that another developer comes up and they make a change to one of the files. So they're going to change this file. This is not for conflicts. This is just so you can have a working version of the code. So here we're just going to put puts another feature here, and then I'm going to hit save or commit changes. So now we have other things happening in the application. So other developers are pushing up changes. We have all kinds of stuff like that happening as I am working on my special branch. So I'm working through this feature, I'm building things out, and let's imagine that I have no idea what's actually going on in the rest of the world. So if I hit get status, just so you can see, let's take a look at this ASDF file locally. So I have the ASDF file. You can see it doesn't have that other line. So I'm going to get status, get add, and just say working on special feature. And then what I'm going to do is come back, and I want to make sure that I'm working alongside all the other developers. And this is something, I'm actually working on a project with Slate right now that specifically this is something I'm doing where I'm taking kind of a large feature and I'm working on it while they're working on a bunch of other things. I want to make sure that I stay up to date with what they're doing. So I will constantly, usually at least once a day, I'll check out master. I don't have any changes here, and I'll run git pull. What git pull is going to do is it's bringing down, there were no conflicts, and it's bringing down the changes like we saw, the changes that the other developer added here. Now, I don't have to do git status because I'm already on master, but now if I type in git checkout special branch, if I open up my ASDF file, you can see I'm still at the old version. Sometimes this is fine. Other times this can actually cause conflicts and can be an issue because let's say that my feature is taking, say, over a week or so to build out. There are who knows how many changes going on in the rest of the application during that time. What I can do is use the command git rebase master. And what this is going to do is it explains, it says first, rewinding head to replay your work on top of it, and then applying work on special feature. So now, if I type in vim ASDF, you can see that we have our new code right here, and everything is working. And we also have the other code that we wrote. So what rebase allows you to do is it allows you to really make sure that you're always lined up with the master branch. You can make all your changes, focus on your feature without worrying that you just spent a week or so building out some feature that doesn't even work with the new version of the code base. So my common pattern that I usually do on this is I'll usually rebase about once a day before I get started, just to take in all the changes from the previous day and then make sure that I'm working on actual code that is that's not going to have any conflicts, and also that I can see all the new methods and classes and things like that that have been added. So that is how you can work with rebasing in Git. And that is everything on the cheat sheet. I'm going to share this with the winner class so that you have it. I know you're not You're going to get into the basics of Git next week, but I still think it was good you were able to go through this, and you can use this cheat sheet kind of as a helpful reference once you actually do start working on that. Now, in both groups, are there any questions before we end the session today? Awesome. Sounds good. Well, it was great talking with everybody. I hope you all, if I do not talk to you beforehand, I hope everyone has a fantastic Thanksgiving. Also, I'm going to be slicing this recording up after we're done. So I'll share the kind of the edited version of it so that you can use this as a reference, and I'll upload it and send it out, the link out to both the groups so you can use it along with the cheat sheet, just kind of like as a reference for as you continue down Git. Because I know one of the biggest things on Git is just practicing it. The more times you do it, the easier it becomes, and sooner or later you're just going to keep doing it and you're not even going to think twice about what you have to enter in, and it's just going to be another tool to add to your tool belt. So great job, everybody. Let me know if you have any questions, and I'll talk with you all after the Thanksgiving break.